Hello and welcome to the third video to probability. Now, very first two videos, the first video talks about introduction to probability. Second video, we solve some questions pertaining what you have learned in the traditional class in the part two. So I'll leave the link to both part one and part two in the video description. So watch those one first before you dive into probability formula, their symbols and notation. First things first, I would like to start by in probability. We have formula we do use to solve problems in probability. Now, how does this work? What are these formulas? We'll look at them one after the other. Before we move into the formulas and examples, I would like to give you, let's say, a problem where it is that problem we'll be using to explain all the probability formulas, the symbols, and notations, right? So let's say I have a sample space. Let's use a sample space of a die. If I have a sample space of a die, for a die, it has a six sample space. That's 1, 2, 3, 4, 5, 6. Here I have a six sample space. So let's say we are given an event A to be equal to event A to be equal to 1, 2, 3, 4, and event B to be equal to 6, 7, 8, and event C to be equal to 1, 7, 8, 9. 1, 7, 8, 9. Alright. So I'm going to be using this particular example here to explain every of the probability formula that we have, their symbols and what their notation. Right. So let's start with this, please. The first one you have there is called marginal probability. Number one, please. We have the marginal probability. All right. Number one is called the marginal probability. Let's do the definition. Marginal probability is the probability of a single event occurring independent of other events or regardless of the outcome of any object of any other event. I said marginal probability is the probability of a single event occurring independent of other events or regardless of the outcome of any other event. So when we say marginal probability, it's the probability that has to do with what you tackling or you focusing on only one event alone without that event depending on other events, right? An individual event, the probability for an individual event is said what that is said to be what a marginal probability. It has to do with probability of a single event occurring, right? Regardless of any other event, right? So you are focusing your mind on what there on just one event. For instance, now if I come here and say find the probability of event A, probability of event A, that stuff is called marginal probability. Why? Because I just picked only A. If I come here and say what probability of B only, what probability of C only, that stuff signifies what the marginal probability is. The probability of a single event occurring, right? Independent is not depending on any other one. It's just standing alone. A single event occurring independent of what there of other events or regardless of the outcome of any other event. For example, now let's say I have to find probability of A. The probability of A will be equal to, we said probability formula that we learned in our very first video. We said the formula probability is what the outcome of the we said the all possible outcome of the what of the event all over total outcome. Now please help me check what is all possible outcome of event A. Event A is having one, two, three, four possible outcome from event A. That gives you 4, right? All over the total of the sample space. We said the total outcome also known as what there sample space is what here 1, 2, 3, 4, 5 is 6. That gives you 4 over 6, and that will be equal to, if I divide the two of them, I'll have my answer to be 4 divided by 6. That gives you 0.666, and it continues. Now this one here is called a marginal probability. Why? Because I did for A alone. I think A is not depending on B or C to leave. A stands alone. In other words, this one refers to what? A marginal probability. Okay, let's change the case. Let's say we want to look for probability of B. Probability that B will occur will be equal to what there we said check out for all possible outcome of event B. For event B, what's the outcome here? 1, 2, 3. That's 3. 3 outcome. 3 over we said all over what there total outcome, also called sample space. That's total outcome here is 6. That gives you 6. This gives you 3 here 1, 3 here 2. That gives you 1 over 2, and that gives you 0.5. This is another typical example of what we refer to as samples A, marginal probability, a probability of a single event occurring. Let's pick C. Probability that C will occur. What will happen in this case? For C, we said total outcome of the event. That gives you 1, 2, 3, 4. That gives you 4 all over what there? The sample space, or you call it total outcome. That gives you 6. Alright, 2 here gives you 2. 2 here gives you 3. If I divide 2 by 3, divide 2 by 3, 2 divided by 3, that gives you 0.66, and it continues like that. So this is the probability of a single event occurring. Probability of A occurring is this. For B occurring is this. For C. So you see that A and B and C do not depend on each other before they can be solved. They are solved individually, right? So as I said earlier, that the probability of a single event occurring independent of other events, or regardless of the outcome of any other event, is called marginal probability. This is how you work with this concept. Number 2 there. Before we move to number two is called union probability. What number 2? Let's explain something, please. Please record this, please. Record that. Guys, we'll be applying some little concept of sets here. Yes. So it will be very interesting if you have watched our video on set theory. Like literally, you will get this thing easily. If you have watched our video on set, if you know set now, by your level, you are watching this video now, and you know set properly, I bet you'll find this interesting. And not that you just know set, you can still recall those concepts. Please, it's one thing to know it. I did it before, but do you understand this thing? I forgot it. It's one thing. So if you know it and you can still recall properly, don't worry, you won't have issue here. But if you don't know it, I would advise you to go and just take my video back, watch my video on set theory. Like literally just watch it to summarize, just you know it already, but you have forgotten some basic concept. Just don't write notes. Just play my video and sit down and watch. That stuff it come back to you, and they can come back here. Now, but for things sake, I'll still explain. Right? Now, let's recover something. We said we're still going forward. Number 1 here is done. Number 2 is union probability. Before I teach you number 2, let's do a quick revision, please. We already know some symbols very well. If I have this in set and I have this in set, What do we call this? What do we call this? Who can remind me? What do we call this? What do we call this insect? What do we call this symbol insect, please? Who can remind me? So here's the thing here. Great teacher does not make great students, right? Great students make themselves great from the instructions of great teachers. So here's my instructions. Whenever you read anything, like you study anything in life, always try to do revision. It's very important. Like literally, in your class, there will be someone that is very good. That guy or that girl is very good. And you know why they are good? Because they are always doing what? Revision. Ask them what they have learned so far. They will remind you instantly. That checking book. Like, this guy is very good. No, he's doing revision. So here's my advice for you. Don't just learn and pass. Learn to read. Learn to assimilate. Learn to understand that thing. So that whenever they ask you, at least you will be able to say something. Most of you learn for exam and after exam, that's all. La cram la pour. That's slang. La cram la pour. Anyways, this stuff here means union. Union. This one here means intersection. Intersection. Alright. Alright, so we have explained this concept as being union. We know this as being what the intersection. Please, if you don't know this thing, I will advise you go and watch our set video. Right? So now listen, here's the task, please. Here's the task. I'll give some questions now. Let's quickly try it to revise that example that I want to give you now. Will remind us of how these two things work. The first one I'm giving you here, A. Let's give A to B. A union B. What's the answer here? B. Let's do B union C. What's the answer here? C. Let's do B intersection C. What's the answer here? And D. Let's do A intersection B. What is the answer here? Okay. Guys, if you can remember properly, when we look at union intersection, right? We said union is simply the combination. Come please. So, all right, we said when it comes to union, union has union has to do with the combination of two or more events, right? In this case, I'm using events, right? So I'm having A and B. I'll combine the members in A and B without repetition. That's union. Union has to do with the way you combine A and B together without repetition. That's A union B. Intersection has to do with what is common between those two events. That's all. So look up please. I'm going to answer this question here. I'm having A union B. I can see A, I can see B. What is the now? Union has to do with what? Combination of the two of them. So if I combine A and B, what will I get? I'll have 1, then 2, then 3, then 4, then 6, then 7, then 8. So this is A union B, right? A union B has to do with you combining A and B together without repetition. What's next one there? The next one here I'm having is A union C. Sorry, B union C. So what's B union C? What will it be? We said union has to do with combining. So B union C gives you a combination of B and C. So for B and C, if you check C and B, C is having 1. So let's start with 1. There must be in order of arrangement. So 1, 1, followed by 6 is the next one. 6, followed by 7 and 8. Now, they are 7 and 8, 7 and 8. Don't come here and write 7 and 8, 7 and 8. We said union has to do with combination of what? Events, 2 or more events without repetition. So, though 7 and 8 occur 2 times here and here, we'll just write 1. That gives you 7 and 8. Then I have 9 left. I have 9. This is the union of C, right? What of B intersection A, B intersection C? When we say intersection, what is common between them? That's intersection. So B intersection C. So for B, I have B here and C. Intersection means what is common between them? 7 and 8, 7 and 8 is common between them. So my answer here is what? 7, 8. Why? Because it's common between B and C. Look at B and A and B. A intersection B. What is common between A and B? Now observe A and B. Is there anything that is common between them? No. That gives you 0, right? So now listen please guys. Whenever mutually exclusive event, all right, whenever the intersection of two events is equal to 0. Now, whenever the intersection of two events is 0, literally, we are looking for common thing between two events, and you are not having any common thing between the two events. Like in this case, like A and B, there is nothing common between them, right? It is called what the mutually exclusive event. Mutually exclusive events are events that their intersection is 0 or their intersection do not exist. So a probability of any event in which is undergoing intersection, whenever it is equal to 0, it is called what the a mutually exclusive event. That's the concept. Right, that is the concept behind mutually exclusive events. So A intersection B is 0. Why? Because there is no common thing between them, and in that case, it leads to something called mutually exclusive event. We'll explain this one in a full video. Don't worry, just get the idea here. We'll still explain later, right? We'll get there. This is like what I want you to note. Now let's move to number 2, please. Number 2 is called union probability. Understand? Number 2 is called union probability. Alright. Union probability. Definition, please. Take down. This is the probability that either event A will occur or event B will occur, of event A and B will occur. I said this is the probability that either event A will occur or event B will occur, of event A and B will occur, right? So we said probability is the probability that either event A or event B will occur, right? So this is how you write probability A or B, right? It has to do with or, right? Don't worry, I'll show you what I'm saying. All right, A or B will occur. Right, the probability that event A or B will occur is said to be what there a union probability. Are all good, guys? Now, please note that. Please note something, please. Note something, please. Note that A or B can still be written as A union B. So what I'm saying is this, in essence, whenever you see or is same thing as union, guys. Or is same thing as what the union. Are we good now? So A or B means A union B. In case you forget what is or, what does or means? Remember union, right? So A union B, same thing as what? A or B. And by the way, this stuff here has to do with what? Addition rule. Whenever you see or has to do with what? Or has to do with what? The addition rule, the probability. We'll still look at it in full detail when we move on. But under general probability, this man is called general probability, or you call it what? Addition rule, right? It is a combination of two events attaching or in their middle. So A or B has to do with what the addition rule, or you call it what general probability. So A or B is same thing as what A union B. So or is attached to what? Union. And it is attached to what? Addition rule. Please see this correction, please. A or B is same thing as what? A union B. And I've shown you how to do A union B before now. A union B. And I said or and union are same thing. So in case you know or as being union, you are cool. In case you know or as not being union, now you can see union here. So I'm saying this that A or B is something as what A union B, and I'll prove it to you as we proceed further. Now, in other words, what then is a formula for A or B, right? Let's use example here we have here to solve some problems, right? So let's say we're asked to find A union B. I want to prove to you A union B, we can get it using idea of set theory. What of A or B? A or B has a formula which I'll give you now, right? So look up this, guys. Let me establish formula first. If I have A or B, A or B is equal to probability of A plus the probability of B minus the probability of A and B. All right. This is the formula for union probability. I will go that the probability that event A or B will occur is equal to the probability of event A occurring plus probability of event B occurring minus the probability of event A and B occurring. Are we good, guys? Now listen, guys, listen to something, please. I will use formula to solve a question, and I'll use this normal A union B to solve a question. They will be the same thing. I said A or B is same thing as what? A union B. Are we good now? Similarly, if I have probability of A or B to be everything here, so everything here can still be expressed as A union B. Let's see how it works, right? Now, in this case here, we said the probability of event A or B occurring is equal to the probability of A occurring plus the probability of B occurring minus the probability of what? A and B occurring. What do we mean? Here's the tax, please. Here's the tax. Here's the tax here. Here's the tax here, please. I'm coming. Here's the tax here, please. Here's the tax here. Please also know that. Also know something, please. Also know something. Note. Also know that when we said or has to do with union. Also, now you see and has to do with what? Intersection. So you can say and here. So I can replace and as what? Intersection, right? Because we know these symbols very well. We know intersection and union very well. Instead of using or and, right? So or and has to do with intersection, or is union. So I can write this formula as the probability of event A or B occurring is equal to what there? The probability of event A occurring plus probability of event B occurring plus probability of what? A intersection what there? Intersection B. Alright. This stuff here and this are still the same thing. The way I told you or and union. Similarly, and intersection are the same thing. Are we good, guys? Now, please listen. Please listen. Please listen something, please. Listen something, please. If you recall properly, when we did look up this, guys. For mutually exclusive events, for mutually exclusive events, I'm coming. All right. So for mutually exclusive events, when we say mutually exclusive event is that when you find the probability of A intersection B and the stuff is zero, it is called what? That mutually exclusive event. So whenever something, I've explained what we mean by this now recently, right? So mutually exclusive event, whenever you find intersection of A and B and it's zero, that becomes mutually exclusive event. So for mutually exclusive event, the probability, observe, the probability of A or B will be equal to what? The probability of A plus what? The probability of B. That's all. A or B will be probability of A plus probability of B. That's all. Because this one here will be zero because it's mutually exclusive. Is zero. So I won't bring it here at all. But in general, the formula itself is just this, right? But in a case whereby I have a mutually exclusive event where probability of A intersection B is zero, it means I will not attach this to the equation. I'll just bring this like this way. How good, guys? Let's see how we can some example to better understand these things here, right? So let's say for instance, all right, the next thing I want to show you here is this. Let's understand something, right? Let's understand something. Let's understand what I mean by mutually exclusive event, right? So let's say I have now this event A or B and event B, for instance, right? Observe event A and B. Event A and B has nothing in common. So if I have this, not use set diagram to draw this in. This event A, event B, they have nothing in common. So that gives you event A is having 1, 2, 3, 4. Event B is having 6, 7, and 8, right? And event B and C, this B and C, right? Why like this? Because B and C has something in common. That's 7 and 8. 7 and 8. Here is 1 and 9 that will be left. Here what will be left? Just 6. Now, if you observe this, you see that B and C has intersection, right? This one is called, this is what? Not, this is what? Not mutually exclusive event, right? Why this one is what? A mutually, this is what? This is mutually exclusive event because it has nothing in common, as you can see, right? So take some example and explain this thing very well, right? So now what I want to explain is this. I want to prove to you, if I use this formula to solve probability of A or B, or I just apply my basic knowledge of A, we said all is what? Union. If I do A union B alone, would the answer be the same thing? Let's see how it works, right? um all right, so let's say I'm asked to find probability of B or C, for instance. Alright. Now, I can do this in two ways and be correct. Now, let's apply formula first. I said the formula is equal to what? The probability of B occurring plus the probability of what? Of C occurring minus the probability of what? B intersection C. B and C, right? The formula I gave you earlier. Follow the pattern. Now, this gives you probability that event B or C will occur is equal to what? Probability of B. Now, what is B? B is what? How many events is B? 1, 2, 3. That gives you 3 over probability is there. So that total of this is what? 6. 6 plus the probability of C. What was C? 1, 2, 3, 4. That's 4 over total is 6 minus the probability of B and C will occur. Now, B intersection. Now, for this particular part, if I'm asked to find probability that B and C will occur. I'll first find the probability. I'll first find B and C first. What's B and C? B intersection C. B and C has what in common? 7 and 8. So B intersection C is 7, 8, right? So the probability now will becomes what? How many is B intersection C is what? 1, 2. There are 2. That gives you 2 over what's total of this thing? That's 6. So the probability that B and C will occur is what? 2 out of what? Out of 6. So I'll come and put 2 over 6. Are we good, guys? In other words, I'll have this is equal to 3 plus 4 minus 2 over 6. This gives you 4 plus okay, this is 5 over 6. This is 5 over 6. 4 yeah, 5 over 6. That's my answer. So using the formula approach, I have 5 over 6. Let's now use normal approach that we know. Probability that B or C will occur. We said let's find B, okay, intersection here. Or means union, right? So let's find union of C, right? Using normal approach. B union C means B and C. What's common? What's common between them is what? 7 and 8 is what is common between B union C, right? So B union C is not this now. When we say union, union is the combination of the two of them. So B union C, B union C, combine B and C together. That's 1, 1, 6, 6, 7, 8, and 9. So combining B and C, B union C is what? Is 1, 6, 7, 8, and 9. So let's now find the probability. The probability that B union C is equal to what? B union C is what? How many is it? 1, 2, 3, 4, 5. That gives you 5 over probability of this. What's the total? That's 6. So observe this answer here and the answer here are what? Are the same thing. So it means that I have proved this for you, that using the formula approach, you still have the same thing, and using a normal set understanding, you still have the same thing. This is a basic understanding behind um, union probability, right? So this is how you get union probability. All right, so let's look at the next one called the joint probability. Let's do the next one called joint probability. Joint probability. Joint probability. All right, let's do joint probability. Okay, number 3 is called the joint probability. Okay, okay. All right, so let's explain joint probability. Definition, please. Joint probability is the probability that both event A and B will occur together simultaneously at the same point. So, for joint probability, is probability that event A and B will occur simultaneously. What we did initially before now was union probability. That one has to do with or. Now, joint probability has to do with what? And I said, note that and and intersection work hand to hand. And I said, connect and or perhaps connect and with what the multiplication rule. Addition rule that we did initially has to do with what or, and has to do with what multiplication what? Multiplication rule, please. Alright, so you have this connection that and means intersection, and is also refers to as what? Multiplication rule. So the probability that A and B will occur is same thing as saying that the probability that event A intersection B, right? That's meaning. So probability of A and B will occur. Same thing as what probability of what A intersection B. Intersection also mean and, right? So don't forget something, please. Recall something that we said something earlier. Recall that we said something that the probability. So we said that A or B. What's or? Or don't forget to is not and or. A or B means what there? A or B means A union B. Now we are saying that A and B means what? A intersection B. So check the difference. So this work with what? The addition rule. Addition rule. Here is what? The what? Multiplication rule. Alright. So note these two stuffs as we proceed. Now, what then is the formula for and joint probability? So if I have the probability that event A and B will occur, this is equal to the probability that event A will occur given that B has already occurred dot the probability that event B will occur. This is the formula to calculate joint probability or multiplication rule probability. So I'm saying is that let's switch it, for instance. So the probability that, let's say this A first and B, let's put B and A. This will be equal to what? The probability that event B will occur, given that A has already occurred, dot the probability of what? Event A occurring. So check the similarity. This is read the probability that event B will occur, given that A has already occurred. This is how you read it. Times what? The probability of what? Event A occurring. So if you want to master this reading, write it down. The probability that event A will occur, given that B has already occurred. Here is probability that B will occur, given that A has already occurred. That's how you read that stuff here. So this formula to calculate joint probability, as you can see on the board, right? Now, for this particular question here, for this particular case here, right? For this particular case here, I'll try to explain something, right? So I'm saying that either I use this formula to solve A and B, or I use just A intersection B, I'll have the same answer, right? That's the place. So let's say for instance, let's look at for independent independent case, right? Event. So let me call it independent event, i.e. So let's say I have independent events. You can see that we said A and B are not independent, they are dependent. They are working simultaneously hand to hand. So you can even see that this is A slash B. It means A, it needs B to survive. B needs A to survive. So they are dependent on each other. But what if in your question they told you they should not be independent? They told you that they should be independent. So please listen and do this, please. For an independent event, so what does independent event means? These are events that does not depend on each other, right? Independent events are events that do not depend on each other. So if I have probability that event A will occur, given that B has already occurred, it is equal to what? The probability of what? Event A occurring. You know why? Because A is not dependent on B. So that gives you A back. This is only this occur only when you have an independent event. How do you know? I will show you. If I have probability that event B will occur, given that A has already occurred, this is equal to what then? The probability of what? Event B occurring. Why? Because it's what? An independent event. An independent event is simply an event that does not depend on each other. So probability of A is A slash B. A comes first. That's probability of A. Probability of B slash A is what probability of what? Of B. So note this concept for independent events. Now, someone asked me that, sir, how will I know that it's independent event or independent event? Here's the tax here. Here's the key take home here. And by the way, please, if I want to write the formula, this formula, I can easily use for this one. I want to write this formula back in terms of independent events. So if I'm asked to find the job probability for an independent event, what will it be? So it means that the probability for A and B in terms of independent events, it means probability of A and B gives you probability of A dot what? The probability of B. Because we just said this one, this is it here, and is what? P of A. So instead of writing probability of A slash B is now what? P of A, and this is P of A dot what? P of B. This is only applied for what? Independent event. Oh, for dependent events, use formula like this. When independent event, you use this one. Or in a case like this, P of B and A, P of B and A equal to what? The P of what? P of B and A. B slash A gives you P of B dot what? P of A. So in a case whereby you are having an independent event, the formula will change to this, not this, please. All right, this is what we refer to as job probability. So someone asked me that, sir, how do I know that this is independent or independent event or dependent event? Here's the key take home here. To understand dependent events and independent events, here's the tax here. So note that in some questions, these are they'll give you, right? I think I've heard of something called replacement and with replacement and without replacement. That's the English they do use, right? So whenever you note, please note this thing, please note for independent events, right? That's i.e. note the word with replacement. So whenever you hear the word with replacement, just know that that stuff is what independent events. But when you hear for dependent events, what you should watch out for is what? Without replacement. So don't worry, in our next video we'll do examples on this, right? So when you hear the word with replacement, it has to do with what? Independent events. When you hear the word without replacement, that's to what the dependent events. These are the two key words to watch out for, to be able to categorize if it's what with dependent or what independent. Now, question please: if I'm going with independent events, will I use formula or this formula here? For independent events, will I use formula or this formula? Of course, for an independent event, i.e., I'll use this formula to solve my A and B, right? But if I'm working with dependent events, I use what? These two formula to solve my what? Dependent event question, please. All right, this is how the joint probability concept works, right? That's joint probability for you. Next up, please, let's look at something else. And before I move on, please, before I move on to something else, let me quickly show you something, please. Let me show something. Let me show something, please, guys. Let me show something. So know this thing, please. Know this different stuff, yeah? It's number two, it's number one, it's number two, right? Know this thing, please. If I have the probability of A and B. We said this can be replaced as what? The probability of what? A intersection B, right? Because they work hand to hand. Also, if a probability of A and B like this, AB like this, if you observe that A comes first, then B comes what? Second, right? If you observe that A appears first before B, and if I have probability of B A, for my own reading here, B comes first, right? Followed by what there? A comes what? Second in this case, right? Here's where I'm going, please. Here's where I'm going. Observe that A comes first before B, and here B comes before A. Here's what I want to, here's what I want to say. So don't mix it up, please. Here is what I want to say, and do not mix it up. So watch this, please. Um, so I'm saying that probability of A and B is same thing as probability of what? B and A, A and B, A and B. So the probability of A and B is same as the probability of what? B and A. They are the same thing. But don't mistake the probability of A, B to be equal to what? The probability of what? B, A. Please, they are not what? The same thing, please. Also, don't mistake probability of A and B to be equal to what there? The probability of A, B. They are not the same, please. This just watch this, please. They are not the same. So note these stuffs, right? So know these stuffs, please. Sit down, read them, understand them, right? Then, so this and this are not the same thing. This and this, A and B, please. A and B. With this, they are not what? The same thing. So let's move on to something that's called number, what is it? Number 3 or 4? 1, 2, 3, 4. Number 4. Let's do conditional probability. All right. Conditional probability. Yeah, conditional probability has to do with the probability that event A will occur given that B has already occurred, and this is equal to the probability of A and B occurring given that B has already occurred. A and B, A and B occurring given that B already occurred. This is your formula approach to conditional probability, right? Probability of A will occur given that B has already occurred is the expression for what? Conditional probability, and this is equal to what? Probability of A and B will occur given that what there B has already occurred. This is conditional what there probability, and if you check it properly, you see that the probability of event A will occur, B will already occur is equal to what? This one here reminds you of something, which is what? The joint probability, right? What about what there? This one remind you about something, which is what? Marginal probability. So the ratio of joint probability, which is this, and marginal probability of a single event, which is this, it says what there? A conditional what there? Probability, as you can see on the board for yourself. So this is how you express conditional probability. If you want to get more examples on conditional probability, more examples on joint probability that we have done, more examples on, now I'm just trying to explain them, formulas and everything. To get more examples, continue watching our videos. I'll still do video A. I'll still do video on each of them and examples attached to each of them one by one. So don't just leave our class like that. Just subscribe to the channel, leave a comment, follow our class up, please. Right? And also support our journey towards this video creation, right? So you have this for conditional probability, right? So this is how it works. So if I want to write it in a symbolic form, right? So I want to write this in the symbolic form. It could be expressed as the probability of event A occurring, given that B has already occurred. What the probability of what event A and event B and its intersection occurring, given that what probability of what B has already occurred. It can be this case if I choose to swap it, probability of B will occur, given that A has already occurred, is equal to what the probability of event B and or intersection A, or the probability of what of A. So observe it that this is the same thing. That's the same approach, right? This is how you calculate for what probability of what conditional probability per se. I'll some examples on this stuff one by one. Just keep on watching our videos, right? So next thing there's something called um, bias theorem, right? Let's look at the concept of bias theorem, right? What does this say, right? Put on please under this please bias theorem please put on please. Another way in which you can calculate the probability of A will occur given that B has already occurred is known as bias theorem, right? So let's say for instance the probability of A has already occurred. A will occur given that B has already occurred is equal to the probability of A will occur. B has already occurred times probability of what? Of B will occur. All over what there? The probability of B will occur. So this is another way of calculating A will occur, B will already occur. Instead of using this approach, you cannot use this approach. And by the way, this and this are still the same thing because we know the probability of A and B is this. Check a formula for probability of A intersection B that I gave you. Check formula for A and B. Check formula there. Your formula in your note, check it and check this one. They are the same thing. So probability of A and B, when I taught you then, I said the probability of what? The probability of what? A will occur, B will not occur, dot probability of B. I gave in the last class, right? So this stuff here is the same thing as what? As this one here. Then this one comes back here. That's all, basically, right? This is like the concept behind bias theorem. It has to do with the breakdown of the original one, right? That's like the concept there. Right. So I have this probability. Now, finally, let's look at negation probability. Negation probability. Finally, let's look at um, negation probability. Let's do number 5. Let's do negation probability. All right. This is given by P of A complement is equal to 1 minus what there P of A. This is what we refer to as negation probability. So definition please. The probability that the complement of A will occur is 1 minus probability that A will occur. So the probability of complement of A will occur is equal to 1 minus what the probability of what A will occur. This is what we refer to as what negation what probability. The probability that A complement will occur is equal to what 1 minus what probability of what A will occur. So let's say I have sample space to be 1, 2, 3, 4, 5, 6, 7, 8, 9, for instance, and I'm having A as to be 1, 2, 3, 4, right? A to be this. 134. Right? So let's find the negation of A. So find negation of A, I need two things. One is there, I need P of A. So P of A, probability of A will occur is equal to A. Probability of A is what? 1, 2, 3, 4. That's 4. All over what there? Probability has to do with sample space. All over sample space, that's 9. So it means that to get the negation, probability of A complement is equal to what there? 1 minus what? Probability of A, and that's 4 over 9. That's 4 over 9. This one gives you 9 minus 4 over 9, and this gives you that's 5 over 9. 5 over 9. So 5 over 9 becomes my answer to that negation problem, right? Some textbooks use probability of something like this. A. This stuff still represent negation, right? Negation. Either you use this complement or this. You say complement, like negation. That's like some textbooks use this symbol, right, in quotes. So this is like the concept behind um, probability formula, the symbols and their what there and their notation, as we have discussed earlier. In our next class, we'll be looking at probability of complementary events and simple space in our next class. So do what our next class. Now, if you're interested in examples for each of these, what's it called? For each of these probability formulas, example on them individually, right? Keep on watching our video. I will do the example for each of them in our future videos, right? As soon as possible. See you guys in the next class and welcome to Excellent Link Academy. If you're interested in assisting our journey, do well to like this video also, subscribe to our channel, share it with your friends and classmates so they can learn too, and also reach out to me if you are willing to support our journey. We need equipment that we're using to teach, right? We need equipment. So if you're just interested, reach out to me. I will explain what we need to you, and whatever you can assist with, we'll proceed with the future stuff there. See you and welcome to Excellent Link Academy.
Hold on. Before you continue this lesson, I need to tell you something important. If you've been struggling with studying, losing motivation, or you feel like you're working hard, but your results aren't showing, this is for you. I recently released a powerful book titled The Shortcut to Academic Success. It is a simple, practical guide that shows you exactly how to study smarter, stay focused, remember more, and achieve outstanding results without stress. This book is not theory. It's a step-by-step roadmap I created after years of teaching students and understanding what truly works. Inside, you'll discover proven study techniques, exam strategies, productivity hacks, memory boosters, and secrets top students use every day. Whether you are in secondary school, university, or preparing for any exam, this book will transform the way you learn and help you reach your academic goals faster. And the best part? It costs only 2,000 Nigerian nairas, less than the price of a snack, but the value inside can change your entire academic journey. If you truly want to upgrade your grades and finally take control of your learning, don't wait. Get your copy of The Shortcut to Academic Success today. Your future self will thank you.